On this video, you'll find the answers to the Algebra 1 pretest and at least one process to work it out. You can pause the video at any time. I will pause it at the beginning of each question. The first one was a most missed question. The way to avoid a problem on this one is anytime you have something squared, just write it twice. So this was a binomial squared, so I wrote it out twice and then multiplied the terms. So you could think of distribution, FOIL, or use the box method. But always show your work on that problem. It's really easy to make a silly error. The second one, your job is to decide what you did to the current one to get to the next one. So since we're always adding 5, to get the next one, we'll take the now one and add 5. So I made a chart out too. That's helpful. The third one, you know what they've raised, so that's your starting value, and this is how much per week. And if you have to have at least 1,350, that means you'd be happy with that much or more. So greater than or equal to. Number 4, they took y equals 2x minus 4 and they doubled the slope and they gave you a new equation. So probably easiest just to graph it with the y-intercept and the slope of 4. So go up 4 over 1. And you can see where the x-intercept, which is where it crosses the x-axis, and the y-intercept, which is where the line crosses the y-axis, and you can compare them. So you see the x-intercept is different than the original, the y-intercept remains the same. Another way, more pure math way to do that is you could also find that you'll have the y-intercept when x is 0 and plug that as 0 in and solve. And you'll have the x-intercept when y is 0 and just plug that in to solve. Number 5 is a problem that you could do in several different ways. A pure math way would be just factoring it. So if you're good at factoring, always look for the common factor first and try factoring, and you should get the right answer. If you feel like you're not so great at that, you could work back by taking the answer, multiplying it out. FOIL is one method. You could use other methods until you get that correct answer. So this one wasn't right, A wasn't right. And a third way that should always work for you is you could graph the original. So this is 6x squared plus 15x minus 36, right, in the y equals screen, and then graph all the rest of those and see if they're the same. So I will show you how to do that. So on my graphing calculator, I'm going to go to the y equals screen. I'm just going to enter in the 6x squared plus 15x minus 36. And I can graph that if I want now, but then I'll graph the first one just to see if that's the right answer. I'm going to type it in exactly as it is. So 2x minus 3 and x plus 4. When I graph that, I can go to Zoom Standard just to start off, especially if I'm borrowing a calculator. I graph it. There's my first one, and there's my second one, and I can see that it's not exactly the same, so that's not my answer. So I could go back to my y equals screen. So if I was using that method, I would cross off the first one, I would type in the second one, and continue on. So I'm going to do one more and then you can do the rest on your own. I will try, how about I'll try the one that I know is the answer, the 3 times the quantity 2x minus 3. So I'm back on my y equals screen. I'm going to go down to this one, and I really don't want that anymore. I could clear it off, or I could just turn it off by turning off the equal sign. And since that equal sign is not shaded, I know that it won't graph it. And I'm going to type in the other one. So I will type that in exactly as it is. And I usually have to check my screen to make sure I'm okay. And since I already, let's see, I missed my right parenthesis here, so that'll change things. So I'm going to insert that, second insert, and put that in there. So that looks better. 2x minus 3, x plus 4. And I've got a 3 out in front. Let me make sure I did that okay. Yep. All right, I'm going to graph that. There's the first one. And there's the second one. If I'm not sure about that, I could go to this, back to the y equals screen, go to the one that I think is the answer. I could go over to the left of y equals and change the way it graphs. So I could do a shaded graph. I like this bubble, and it'll kind of show you where it's graphing the second one. So I might need to turn it off and on. I'll turn it off and back on, and it should graph it for me. So there's the first one, and the second one is traced right on top of that. So I know that it's the same one. Number 6, starting value of 50, $20 per hour. And we know this is your starting value, which is your y-intercept, and this is your slope. Number 7, or it's the solution. Several ways you could do that. I just did pure math by solving. It's a quadratic, so you always want to set it equal to 0 first. And then you could factor it. Don't forget the second step of once you factor it, to set each factor equal to 0 and solve. So I can see my two solutions are -2 and 1, which is C. I could graph it and see where it crosses the x-axis. Or I could also work backwards and make sure the answers work. So I could put a 1 in for everywhere there is an x on the left side and make sure it equals the thing on the right side when I put a 1 in. And then try a -2. Make sure it works on both sides. So both answers must work. Don't stop too soon on that. But I could easily take this when it's set equal to 0 right here and graph that as well. So the x squared plus x minus 2. So I'm going to go to my calculator. I'm going to clear off that everything that's on there. And just enter that equation. So once it's set equal to 0, that's an easy way to do it. It's not the only way. X squared plus x minus 2. If I'm sure about what I'm doing, I can enter that in. So x squared plus x minus 2. And I want to see if it crosses at -2 and 1. I could do a trace to see where that is. So I just press trace, and I move my cursor up. Looks like it's about 1. You can also use the 0 function if you know how to do that on the calculator. And here is also -2. So great way to do that. Number 8, you can draw in your line where it's approximately your line. I'm not that good with the Promethean board here, but All right, I could sketch in where I think that line is, where it follows the data. And I can see it looks like my y-intercept is somewhere close to 110. Could be a little bit lower than that. And then, so my y-intercept's about 110, so that means that there's no way it can be 85, because that's too low. 85 is about right here. Oops, right there. And so it can't be 85. And I notice that I have a negative slope, so that tells me it has to be A. Number 9, an easy way to do that is just graph them all in the graphing calculator and see which one's not aligned. So just go to your y equals screen and graph those. I'll let you do that since they're already solved for y. Take advantage of that calculator. Number 10, everyone got this one correct, so it's probably the way you did that. Number 11, notice I underlined on my test. You can do that on yours, make notes. So I noticed that the school R was increasing by 20 and it started with 200, so that's where I got this equation. And then school, so there's that information right there. Yeah, it's hard to see. And then school T had a starting value of 400 and it was decreasing, so I had minus 30. So it could have been a reading error on that one. And then I needed to see when they were equal, so I set those two expressions equal to each other and solved for x. Number 12. Factor them. Just try factoring using trial and error. These are not bad. The leading coefficient is a 1, so you know you have to have an x and x, and then trial and error to get the outer and the inners to add to the center one, and the last times the last to multiply by the last one. So I factored them, and since we weren't supposed to be able to factor it, I realized there was no way I could get a positive 2 when I was multiplying a 1 by 1 to get a negative 1. So there was no way to do that one, so Mel was correct. Number 13. I first noticed that the T, or the counter, was going up by 1. You want to check that to see what's going on in your pattern. So since it was, I thought I would check the difference between the consecutive values. They were not the same, so I knew it wasn't linear, so I started to look at a different pattern. And I noticed that this was 3 and this was 3 times 3, and I saw a pattern where the exponent was actually the counter. So that's why I knew it was 3 to the t, which is exponential. If it was squared, it would be quadratic, and absolute value would have the absolute value bars on it. It'd always be positive. For this one, you want to simplify within the parentheses first, if possible. So when I thought about 2x to the third, 2, and then I wrote out 3 x's over x, and I canceled out one of the x's, leaving me 2x squared, which then I took to the 5th power, which means 2 to the 5th, and x squared to the 5th, and you would multiply those. So that's why it's 32x to the 10th. Number 15. It's a scatter plot, and we have a line of best fit, so you can see where I sketched in a line, and it looks like it's a horizontal line going through 100. You could have graphed this. This has a slope of 0 and a y-intercept of 100, and so it's D. Number 16. For this one, we were told that the two areas are equal, so my thinking was that area of a rectangle equals area of a triangle. So the rectangle's base times height has to equal the triangle's 1/2 of its base and its height, and I just substituted in the base of the rectangle times the height of the rectangle, 1/2 the base of the triangle times the height of the triangle. I did some multiplying. I distributed here to clean it up. I multiplied here. I went ahead and brought this 8x and multiply it by 1/2 to get 4x, and then brought down the x plus 1, and then later I distributed the 4x to the x plus 1. And then I remembered the rule of solving quadratics. You want to set everything equal to 0. And so when I did, the 1x minus 4x was a negative 3x, and 5x squared minus 4x was x squared, and I didn't have a constant. So I just factored out a common factor, which we should always look for, and I realized my two factors were x and x minus 3, set my factors equal to 0, and solved them. So my answers for x are 0 or 3, but the question was, what's the area of the rectangle? So here's my rectangle. Since one side is x, I know my answer can't be 0 because that's the side of a rectangle. So it has to be something. So I can get rid of 0. My x value must be 3. So now I know it's a 3 by, and when I plug in that 3 there, I know it's a 3 by 16 rectangle, which is 48. So that's why the answer is B. Number 17, she's graphed this, y equals x squared plus 1, and then he graphs y equals x squared plus 3. We should know that this last value moves the parabola up 2, because 3 minus 1 is 2, or you could just graph both and just notice the difference and then describe it with the answer. So that's why that answer is 2 units up. Number 18, I think that the spacing and formatting got a little bit messed up on this one. It was hard for me to tell where everything was. But A, I believe, is just the f of x equals 3x plus 1, which is the same as y equals 3x plus 1. You can always interchange a y or f of x. B was the table, and I noticed I was trying to compare it to see if it was the same. So it looked like it was 3x plus 1. So I plugged in, I got a negative 14 there. But here I did not get what was in the table. I got a 13 instead of a 12 and a 37 instead of a 36. So I knew there was a problem there. On this one, it's a mapping format. And it looks like every negative 2 maps to negative 5, which still fits my function up here. F of x equals 3x plus 1. And so I plugged in the negative 2, make sure I got a negative 5, a 3, and I got a 10, and a 6, and I got a negative 19. So that one looked okay. And the last one was a graph. And so I could use the y-intercept, which was 1, and then up 3 over 1, up 3 over 1, and see that was my slope. So that was the same. So it looks to me like the one that is different would be B, because it doesn't follow that pattern. 19, what are the x-intercepts? A couple ways you could do that. You could factor it. So if you're finding the x-intercept, you're letting y equal 0, and I factored it, set the factors equal to 0, and that gave me my two solutions. Now remember, those are the x-intercepts when y is 0, so that's why it's the coordinates, negative 2, 0, negative 1, 0. You could also graph it exactly as is in the calculator like we did before. You could use trace to locate the x values, or use the 0 feature in the calculator. So I will show you that one more time. So I'm going to clear out what's in my calculator. I went to the y equals screen, and I'm clearing that out. And I'm going to type that equation in just as I see it. Y equals x squared plus 3x plus 2. So there's my equation. My equal sign is on, and I'm going to graph that to see what it looks like. And it's hard to tell, but I could use trace, or I could use the 0 function. I could zoom in a little to see. But I'm going to use trace, and my cursor right now is at the y-intercept. So I'm going to bring it down, and I'm looking for when, I'm looking for a 0, so I'm looking for when y is 0 or closest to 0. It's pretty close right there when x is really close to negative 1, and it's going to go below it. And I'm going to see when y is 0 again, or really close to negative 2. So then I can look at my answers, and it seems like at negative 2, 0 and at negative 1, 0, it is correct. So I could always go through and do the problems and then go back and just check them by graphing. So any of the ones that I could possibly check by graphing, that would be a great way to do that. All right, on number 20, which expression represents the output of the nth term? So your job is to notice if these are increasing by 1 and these are going up by a constant value, so we know it's linear. The constant change is going to be your slope, and so I wrote y equals 2n, and then see if that works. So for me, I plugged in the 3, y equals 2 times 3, which is 6, but it's supposed to be 5, so I'll fix that by subtracting 1. And then I will always check that again. I'm going to go to 4. I'll plug a 4 in for n. Y equals 2 times 4, which is 8, minus 1, which is 7. So I know my expression works. Number 21 was one of the most missed questions. So it's been a while, I guess, since we solved systems. Several ways you could do this. You could use your calculator. The pure math method probably would be substitution. So you're going to take all of 2x minus 3 and plug it in for y in this other equation. So that's what I did. 4x minus 3 times whatever y was. And then I just distributed, combined my like terms, and solved for x. So I got x is negative 11. Once x is negative 11, I can choose either equation to plug negative 11 in. So 2 times negative 11 minus 3 is negative 25. So I know it's negative 11, negative 25. A smart thing to do would be to check that again in both equations. Another way to do that, if you're concerned about solving systems, take the x and y values and plug them in. Remember, this is your x. That's your x, and this is your y. And if you're going to use this method, you have to plug it in both equations. So take negative 11, plug that in for x, negative 25, plug it in for y, and make sure both sides are equal on both equations. Do the same thing down here. 4 times negative 11 minus 3 times negative 25. If that is 31 and it worked in this equation, that's your solution. But don't stop with the first one. Standardized tests, they'll probably have it where the first equation will work because they know people will stop too soon. So they're testing to see if you know to go ahead and check them in both. So that's a great way to do it if you're not so sure about solving systems. Number 22 asks for the median. Make sure you write them in order. So once they're written in order, you can find the median. So I found the original median was 13.5. They didn't ask just for that. They said that you have a student that is transferring to another school, so I got rid of the 43 and that changed our median. And so my new median was 12, and it asked how much the median changed. So I just took 13.5 minus 12 and got 1.5. Number 23, given those two equations, I had to compare them. So what made sense was to, since this was in slope-intercept form, I wanted to put this in slope-intercept form. And that just required me to divide everything by -2, but that looked a little confusing since that was 1/2. So instead, I multiplied everything by -1/2. So I multiplied by -1/2 for every single term gets multiplied by -1/2. And once I did that, I cleaned it up and I realized that it was the same equation. Number 24. Same thing. What do you do with the one to get the next one? So it looks like here we're always multiplying by -2, so -2 times the current one will give you the next one. Number 25, be careful with these, write these out. So I rewrote the original, clean that off. I rewrote the original expression, and I had to do my multiplication first before I can do any addition or subtraction. So then I used FOIL, but you could use the box if you want. So first times first, outer times outer, inner times inner, and last times last. And I wrote all my terms. And then I just started combining. We're not solving anything, we're just writing an expression. So I knew 2x squared and negative 2x squared were gone. So then I combined all my x's. If you notice, I underlined them with a line, and then I underlined all my constants with a squiggle just so I could combine those like terms. But that gave me that answer. 26 was a most missed question. So I took a minute to look at this one. On your paper, you may want to shade this in because it didn't copy really well. Or you might have it okay on yours, I don't know. Didn't copy on my scan, but this is the section that's shaded. So I'm going to notice if it is a system like this where it's shaded. And the other thing I notice is that this is a dashed line and this is a solid line. So look at it from each line's point of view. So let's start with this one. So I notice about this dashed line is it has a positive slope. The shading is below it, so it's less than. And I notice that the y-intercept is negative down here. So positive slope, less than shading, negative y-intercept. So I thought about y equals mx plus b form, but I wanted it to be less than. And then I just thought about my slope. It should be positive because it's rising, and y-intercept should be negative. So I knew I needed an inequality that looked like that. For the solid line, I know it's a negative slope. I know it's shaded above it, so it's greater than shading, or equal to actually, because it's a solid line. And I know the y-intercept is up here, so it's positive. So I was looking for y is greater than or equal to negative slope, positive y-intercept. And when I just narrowed it down like that, I noticed that this was the only one that could have worked, because here I have less than or equal to, which is not even one of my choices. So I got rid of that one right away. This one I have greater than, which is not one of my choices, and a less than or equal to. And this one I have greater than or equal to and a less than, but my greater than or equal to has a positive slope and a negative y-intercept, and my less than or equal to has a negative slope and a positive y-intercept. So by understanding this shading and the way you graph a line, I didn't have to do much more work than just observing on that one. All right, number 27, what are the x-intercepts? The x-intercepts are where the parabola crosses the x-axis. So I wrote the coordinates down. I had to go over 5 and up none, so 5, 0. I had to go left 1 and up none, so negative 1, 0. Circle them, and that's my answer. Number 28, which equation represents a linear function? I put on here, if you're not sure, solve them for y and graph. So I did the first, I guess the second one B. So I took x, y, I divided both sides by x, and then you can graph it and you realize it's not a line. All you care about is if it's a line or not. So it's asking if it's linear. Hopefully you recognize that as the y equals mx plus b form. Number 29, what is the y coordinate in the solution? So you're going to have to solve this one to be able to get the y coordinate. Both of these are in standard form. So I would probably solve this one by elimination, because I noticed that I can easily get the y values to have opposite coefficients. So this is a positive 2, I could make that a negative 2. So I multiplied the whole bottom equation by 2, and I left the top equation alone. So my top equation is right here, left it alone. Bottom equation gets multiplied by 2, everything's doubled. So as long as I do that to both sides, I'm good. And to eliminate, we'll go ahead and add those. Negative 3 plus 8 is 5x. This goes away. And 6 plus 4 is 10, so x is 2. But that's not my answer. I want to know the y coordinate. So when x is 2, you can substitute that into either equation. And I chose the bottom one. So 4 times 2 minus y is going to equal 2, which is 8 minus y is 2. Subtracted 8 on both sides, so I got y is negative 6, and I got 6. You really should check that in the other equation. So we plug that in the second one. You should plug in the fact that x is 2 and y is 6 in the first equation. And so you feel confident with that. And here you can check it and make sure it's right. Another way you could do that is solve them both for y and graph them both and just see where they cross. So that's the solution would be where they intersect. So you could do that as well. Number 30, which equation describes the line of best fit for the scatter plot? Again, you could just sketch in a line or imagine where that line would be. I had one in here, but you can't really see it, so I'll just kind of lightly draw kind of the general idea here. Oops. Let's see if that's good enough. If not, we'll have to do that a little bit better. All right, 1, 2, 3, 4, 5. I know it's 5 or greater. It doesn't look like the y-intercept could be 4, so I'm going to get rid of A and C. And I notice my slope is negative, and I probably should get out my straight edge and do a little bit better job. So I'm going to go down 2 over 3 would be better than down 3 over 2. That would be too steep. So that's why I chose B. All right, drew my line a little bit better. It's still my y-intercept's 5. My slope is closer to down 2 over 3 than it is to down 3 over 2. That would be too steep. Number 31, if you forget the exponent rules, an easy way to do that is just to list them all out. So I just put 4 over 8, which I knew that was 1/2, so I just simplified that. But x to the third, write it 3 x's. X to the fifth, write 5 x's. Y to the third over y squared. And then just start crossing off and see what you have left. So 2 of my y's go away, I'm left with 1 y on top. 3 of my x's go away, and I'm left with 2 on bottom. And then this was a 1/2, so I have y over 2x squared. So write it out and simplify, and you don't have to worry about the rules. The rules are, though, you subtract exponents when you're dividing, so you could do that as well. 3 minus 5 is -2, and 3 minus 2 is 1, and you don't want a negative exponent, so if your exponent's negative and it's on the top, you'll put it on the bottom to make it positive. So that's another way to do that as well. I've got the line on there from before. Let me erase that. All right, 32. You want to know the general formula, distance equals rate times time. And once you have that, draw a picture. I always would, to help me keep these kinds of problems straight. Sometimes they'll be going in the same direction. In this case, they're going opposite directions. And so it said that Sam's rate was 15 more than Candy's, so that's where I have the R plus 15 in the R. Their time was the same. They both started at the same time and started running. And all I did, I used the formula distance equals rate times time to take rate times time, and that gave me the distance. So I just showed it here, and then the 2R. Since I know the total distance is 230, so if Sam went this way and Candy went this way, I know that there are 2 distances added up to 30, so I just took Candy's distance plus Sam's distance equals 230, and that's how I got that equation right there. Distributed, combine like terms, and solve for R. So once I solve for R completely, I get R is 50, so I know Candy's rate is 50. When I multiply that by 2, I get her total distance, which is 2 times 50 or 100. And I think it said in the problem she gets 20 miles per gallon. So how many gallons did she need? So 100 divided by 20 is 5. 33, there's the graph y equals x squared. And if we translated it, what would be the new y-intercept? We see the y-intercept right now is at 0, 0. If we moved it up 2, it would be right up here, and so 0, 2. You could also graph it on your graphing calculator exactly as is and see that and use your trace feature to see where it is. Number 34, Most students got this one correct, so I'll let you just reread it. Chances are you probably did the check the choices way of doing this, just trial and error. If we had, you know, how many nickels do we have? So 5 nickels, and you would have 30 dimes, and then multiply that out and see if you get the correct amount. I did that one. That was 325, but we wanted 250. Trial and error is probably a great way to do this problem. My equation was nickels plus dimes has to equal 35, and then I gave them value, so an amount equation and a value equation, and I solved the system. But I also like solving systems. Number 35, a line is represented by the equation. What is another way to represent the same line? So I took that and just wrote it in y equals mx plus b form, and I don't know why that's there. And then got it to look just like the one on the paper. 36, plot them. So I just plotted the points, and I noticed that it wasn't the same line. It didn't form lines that were perpendicular, because that would be coming right at a 90-degree angle. And the lines are not intersecting, because at every point it's the same distance apart, so they are parallel. And 37, since these were increasing by 1, I checked this out and I noticed it wasn't linear, so I usually check that first, and then I noticed that you were multiplying. So if you multiply by 5 and multiply by 5, it worked down here as well. Multiply by 5, multiply 3/5 by 5, and I get 3. And so I know I was always multiplying by 5, and so then I used this, and I realized that if I had 5 times 3 is 15, and a little trial and error there. Number 38, you just need to extend your line a little bit. So you can see that lightly I drew the line in there. Just try to find that line of best fit. And after watching 10 hours of TV, 10 would be here. It looks like probably my line would extend a little bit below. And so 50 would be, it seems like it would be right on the line, a little below that. 48 makes sense. It's definitely not more. This is way too much, and 41 is too little. So it's an approximation anyway. Get as close as possible. Number 39, solving inequalities. So it looks like we needed some review on solving inequalities. You're going to solve an inequality exactly as you would an equation, except for one thing. So here's my original. I decided I wanted to get rid of the 1/3 first, so I multiplied both sides by 3/1. That's the same as an equation. Once I multiplied it, that 3 and 1/3 went away, so I was left with 6 minus x, and this became -6. Like an equation, I subtracted 6 on both sides, so I get -x and -12. Notice I'm just bringing down that inequality sign. At this point, though, to get rid of the negative, I'm going to need to divide by -1. If you divide or multiply by a -1, you need to flip the sign. So this became positive. -12 divided by -1 is 12, and that flipped over. So that's how I got my correct answer. Number 40, you can just look at that one and compare with how you did it. He told me the cost was C, and this is the amount of people. So the price apparently affects the amount of people that are going to go there, so that makes sense. And so I just plugged in. If the cost was $1, I plugged in a 1 into my C, and I got 75 minus 5, which was 70. The question was, which ticket price will generate the most income? So at a cost of $1 per ticket, the number of people, so 70 times 1 is 70. And I just did that for all of them. And so you would think that, you know, this high price of $15 would generate some income, but not as many people are willing to pay that, apparently, according to the expression. We don't know how they got that, and so that's a 0. So my most income would be $7.50 ticket.